Thanks to Angry Birds for sponsoring today's video. The launch of a spacecraft is always a nervous moment. Countless things can go wrong, ranging from a failure to launch to a catastrophic explosion. The landing is the same. One faulty piece of hardware could be the difference between a successful arrival and a mission-ending crash. You might have thought that the time period in between, however, would be a time to sit back and relax. So surely, after the asteroid-exploring NASA Lucy probe had successfully taken off, it would be safe until it reached the asteroids it hoped to study. Surely it simply drifted through the dark silence of space. Nothing could be going on that was that dangerous or noteworthy, right? Think again. Lucy had been fighting for her life and has been performing dangerous maneuvers for the last year. I'm Alex McColgan and you're watching Astrum. Join with me today as we watch the nail-biting journey of Lucy as it flies through the first phase of the most difficult, complicated tour of our solar system to date. I can honestly say, when I started researching this, I did not expect this middle part of the story to be quite so adventurous. It began just hours after Lucy's launch. Lucy is a spacecraft with a unique mission. The Trojan asteroids are some of the least explored asteroids in our solar system, in spite of the fact that they are found relatively close to home, along the same orbital line as Jupiter. Scientists before 1906 had only hypothesized their existence, and almost all of them, nearly 4,600 asteroids to date, have only been spotted since the year 2000 as our instruments improved. Many more may still be out there, just waiting to be discovered. These asteroids are fascinating, not just because they are so unexplored, but because they act like a fossil record for the early days of our solar system's existence. And so, Lucy was tasked with the mission of visiting 7 of those ancient fossils in a single trip, a record-setting number for a single spacecraft. It would not be an easy journey. These asteroids exist in clumps at points 60 degrees ahead of and behind Jupiter in its orbit, in areas known as Lagrange points, and Lucy had to visit both groups. This would require a complicated figure-of-8 trajectory that used the Earth's gravity multiple times to slingshot itself around the solar system. But Lucy came equipped with the tools it needed to get the job done. Strong thrusters, powerful cameras to photograph the asteroids it visited, a thermal infrared spectrometer to learn about the structure and composition of these objects, and 2 massive 7.3 meter diameter solar panels to give it the vital energy it needs to be able to operate. The Trojans orbit around 740 million kilometers from the Sun, and at this distance the sunlight is so faint that it's at the limit of where a solar-powered spacecraft can function. Lucy's panels had to be that big, or else it wouldn't be able to keep itself powered. Which is why it was such a problem when, just hours after launch, NASA realized that Lucy's panels had failed to fully open. Due to their massive size, these panels had to be folded up during launch to allow the craft to fit inside its Atlas V rocket. Upon reaching space, however, motors were meant to activate, pulling at lanyards that would deploy the solar panels, unfolding them like 2 massive sails. However, while one panel fully extended and latched into its open position, the second panel never latched open, and it somehow failed to fully deploy. Although Lucy had cameras, none of these pointed at the spacecraft itself, so scientists had no idea what had gone wrong, or even how far along the second solar panel had unfolded, making finding a solution that much more difficult. There was also time to consider. Lucy would need to solve this problem before it got to the Trojans, or before it performed any of the massive thruster burns that would be required for its journey, or else the unattached panel could bend and snap, and Lucy could run out of power, spelling an end to the mission. NASA started looking for clues. They started with the panel's power production. By looking at how much electricity the panel was producing, they calculated that Lucy's solar panel had to be open between 75 and 95%. This was a good sign. Lucy would have enough power while near Earth. They had some time to fix the issue. But they needed more precise information than this to enact a repair, and it was like trying to find out how many fingers someone was holding up when you are blindfolded. But over the course of the next few months, scientists found a way to do exactly that. By activating Lucy's thrusters ever so slightly, they started vibrating Lucy. Lucy's onboard sensors recorded these vibrations through things like tension readings in its panels, and by checking how these readings fluctuated, they could figure out exactly how far open the panel had unfurled. Sort of like figuring out how many fingers someone had raised by getting them to move their arm and then listening to the sound their fingers made through the air, or more precisely, by recording the strain in the person's arm. It wouldn't be something you could do by ear or touch, but with the right sensors and precise enough computer models, it was possible, and NASA has some very powerful computers. Using this data, they worked out the source of the issue. It had to be an unspooled lanyard, part of the process of pulling the solar panel open. But somehow this lanyard had become tangled during liftoff and had jammed before completely spooling. Scientists recreated the problem back on Earth using a model version of Lucy and brainstormed what to do. They now had more accurate data. Lucy's panel was open between 345 degrees and 360 degrees. It was generating 90% of its expected power. They could attempt to use Lucy's onboard motors, both main and backup, to yank the lanyard, hoping to open it further, but this could cause more problems if something snapped. Or they could just say that 90% was enough and leave it as it was, but this might leave Lucy vulnerable during the high G-forces of its thrusts. If the panel broke because it wasn't properly tensioned, the mission could be over. Even if that didn't happen, juggling the reduced power might mean Lucy could do less science. In the end, a middle ground was reached. Over the course of the next several months, Lucy underwent a series of very incremental tugs on its lanyard. Little by little, by using the main motor and the backup motor together, doing bursts and then stopping to make sure nothing overheated, NASA got Lucy's panel to open up between 353 degrees and 357 degrees, almost the full 360. It still wasn't quite latched, but the tension provided by the lanyard was now enough that by August 2022, a full 10 months after launch, NASA was confident that Lucy would be able to complete its high G maneuvers. Which was excellent timing, because just 2 months later, Lucy would be performing one of those very maneuvers. Lucy had by now returned to the Earth. Its flight plan had taken it out in a wide, pre-planned loop. Now it was back, Lucy would be doing its first major maneuver, a dive into the Earth's gravity well to give its velocity a boost. The physics of this is fascinating. By entering the Earth's gravity from behind relative to its motion, Lucy could use the planet's gravity to increase its subsequent velocity. If, conversely, you came at it from an angle that moved against the planet's motion, you would slow your velocity. Lucy would take advantage of the accelerating version of this plan, diving as close as 350 kilometers to the Earth's surface to take maximum advantage of this gravitational push. But with such a deep dive came additional danger. Because of the influence of mankind, there are now 47,000 satellites and pieces of orbital debris circling above us in space. Lucy would need to safely get past this cloud of potential hazards. Of course, space is large, and the odds of hitting something are relatively low. However, they are not zero. The International Space Station had to change orbit 31 times since 1999 to avoid collisions. And with a number as high as 47,000 different objects, it's difficult to track everything. Just a single missed satellite in the wrong place at the wrong time could intercept Lucy, causing a catastrophic collision. NASA had to start scanning the skies in the days before Lucy's arrival to get up-to-date information of what was now there and what might prove a threat. If there was so much as a 1 in 10,000 chance of something hitting Lucy, NASA would need to change Lucy's course. Help came from an unusual source. The newly formed US Space Force, founded in late 2019, had started cataloging and monitoring objects moving through this area. Both groups have an interest in space and the Earth's orbit, and share a mutual desire for no big collisions to take place up there. Working together, they were able to plot a safe path for Lucy. Lucy crossed our skies on October 16, 2022. It was visible to observers in Western Australia, briefly shining more brightly than the International Space Station in the sky before it passed into Earth's shadow and disappeared from sight. For 20 minutes, it remained completely hidden from view. Then, this time over the western United States, it re-emerged before soaring off into space once more. Lucy used the opportunity to take a photo of the planet, and specifically Ethiopia, as it flew overhead. The original Lucy was a fossil of a human ancestor, over 3 million years old, which was found in Ethiopia in 1974. The Lucy spacecraft was named after this fossil, as a reminder of its own mission to find the fossilized remains of our early solar system. This time not bones, but asteroids. That being said, when naming Lucy, NASA weren't completely above referencing the famous Beatles song, Lucy in the Sky with Diamonds, as they put a disc of lab-grown diamonds on one of Lucy's scientific instruments. For science, of course. And speaking of science, Lucy has not been idle over the last year, even with all that has been going on. In addition to testing its onboard components, NASA took advantage of its position in space to take a look at one of its destination asteroids, known as Polymele, as the Trojan passed in front of a star. This brief snapshot was intended to give scientists a better idea of Polymele's location, size, and shape. However, what they hadn't expected was that Polymele wasn't alone. The star darkened as Polymele passed by it, but then darkened again as a second, smaller object passed by too. Lucy had discovered that Polymele had a small satellite. This small object is yet to be named, but is believed to be 5 kilometers in diameter and orbits the asteroid out at a distance of 200 kilometers. With this new discovery, Lucy added a new destination to its mission. Coupled with another satellite found to be orbiting the asteroid Eurybates, Lucy's total number of targets for study has risen from 7 to 9. I did mention that many more Trojan asteroids were out there to be discovered. After performing another dive into the Earth's gravity well in 2024, Lucy will be arriving at its first destination for study in 2025. It will be starting with the inner main belt C-type asteroid Donald Johansen. While not a Trojan asteroid, the paths lined up nicely for an en route visit to this passing object, so it seemed a shame to waste the opportunity. Lucy will then proceed onto the Trojans themselves, arriving in 2027. By then, it's always possible its list of targets to study will have increased again if more tiny satellites are discovered. So, it has been a busy year for Lucy. The spacecraft has already overcome challenges and made discoveries. If it can overcome the hurdles ahead, it will be a record-setting spacecraft, but the scale of that record remains to be seen. The Trojans are a frontier we have not properly explored. Only time will tell what wonders lay undiscovered in those enigmatic fields of stone. Only time and Lucy, of course. When NASA was sending objects flying through space in precise arcs, landing perfectly at their destination, they did not choose small, irate avians as their vehicle of choice. But then, perhaps that was because no piggies kidnapped their friends. I've been starting to play Angry Birds again, and I must say, while NASA landings are evaluated on how uneventful they are, there's a primal satisfaction to be had in crashing into your target as destructively as possible. The sponsor of today's video, Angry Birds Friends, takes all the charm of the original pig popping game premise, but now it comes with online tournaments containing new levels 3 times a week, so you never run out of stages to play. Also, they've partnered up with Amazon Prime Gaming, so you can claim Amazon Prime rewards in-game. The game is free to download on Android and iOS, and can be played on your PC through the Windows Store and Facebook Games. Use my link in the description below to give it a try for free. Thanks for watching, and thanks to my patrons and members for your support. If you want to support too, check the links in the description below. All the best and see you next time.